We have already studied in part A the calculation of external static pressure for HVAC ducting using duct fittings equivalent length method. Now we will study the calculation of external static pressure for HVAC ducting using another method, that is duct fitting loss coefficient method, based on SMACNA and ASHRAE standard. I have created this Excel sheet for the calculation of HVAC ducting external static pressure based on the basic formulas in SMACNA and ASHRAE standards. The only thing you need to do to fill the duct basic informations like the value for duct dimensions, length, and duct fitting loss coefficient. Then this Excel sheet will automatically calculate the total external static pressure for HVAC ducting. I will do one sample exercise to explain how to calculate duct fittings and accessories loss coefficient from SMACNA tables. I, Engineer Nasir, welcome you to our channel NC Engineering and Technologies. Friends, if you are new to our channel or still you have not subscribed it, please subscribe to our channel so that we can make more studies and bring more videos for you. I will make a sample exercise for the calculation of external static pressure using this drawing, where HU1 is supplying 3600 CFM to a room with the help of 6 number of square ceiling diffuser with tag numbers 1, 2, 3, 4, 5, 6. First we will select the longest or the critical part of the duct, which in our case will start from the HU1 and will go along the duct and will be going up to the last of diffuser. Number 2, we will give the separate tag number to each duct segment and accessories. As in this drawing, we have given the tag number 1 to the fire damper and tag number 2 to the straight duct with size 28 by 16 inch with a length of 1 meter. Similarly, we have given tag number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Number 3, making a table of all duct segments, fittings and accessories showing description, airflow, length and sizes, etc. We have 4 duct fittings in our critical path and we will find the duct fitting loss coefficient C from SMACNA table for these fittings. Number 1, Y branch 28 by 16 dash 20 by 16 then 16 by 12. Another Y branch 20 by 16 dash 16 by 12 dash 16 by 12. Number 3, elbow 90 degree 16 by 12 inch and number 4, transition piece 16 by 12 by 10 by 12 inch. Now we will calculate the value of coefficient for the Y branch having dimension 28 by 16 inch by 20 by 16 and 16 by 12 inch. As you can see from this table, to find the value of coefficient C, we need 3 values: the ratio of AB by AS, the second ratio AB by AC, and the third ratio QB by QC. We have mentioned the values for our Y. You can see in this side we have the CFM 3600 and the size is 28 by 16 inch. The equivalent dia is 22.9. On the base of this dia we have calculated the area is equal to A is equal to 412, which is AC. Similarly, AS is equal to 299 and AB equal to 179. From this value we have calculated the value of these ratios: AB by AS equal to 0.6, AB by AC equal to 0.43 and QB by QC equal to 0.33. Selecting the nearest value for the main coefficient, we have found the value of C equal to minus 0.04. Similarly, for the Y branch 20 by 16, 16 by 12 and 16 by 12, we have find the value of main coefficient C, which is equal to 0.05. Now we will use the table 14 dash to find the pressure loss coefficient for elbow 90 degree. Assuming the short radius main elbow having one main, As you can see, H equal to 12 inch, W equal to 16 inch and R equal to 1.6 inch. The ratio of HW equal to 0.75 and RW equal to 0.01. Selecting this value in the table, RW we have 0.01 and HW we have 0.75. So selecting the nearest value, that is 8. At the intersection of this row and column, we found the value of fitting loss coefficient C for 90-degree elbow, which is equal to 0.52. Transition loss coefficient can be obtained after determining if the fitting is diverging or converging, as we have table 14-12 for converging flow and table 14-11 for diverging flow. As the ratio A1 by A equal to 1.6, then selecting the nearest value from the table, which is equal to 2, and assuming the angle 30-degree, then the value of transition loss coefficient C from the table is equal to 0.05. If instead of using the Y branch we are using the takeoff to take the branch from the main duct, then we need to use this table to find the value of fitting coefficient C. Assuming the dampers fully open, the value of coefficient C at 0 degree will be 0.04. After calculating the value of fitting and accessories loss coefficient, when we apply these value along with the duct basic information in this Excel sheet, it automatically calculates for us the value of total external static pressure for the duct. For the calculation of external static pressure for HVAC ducting, we have this basic formula. Number 1, to calculate the external static pressure for straight duct, we have the formula ESP equal to total straight duct length into friction loss rate, water gauge per 100 feet. And for the duct fittings and accessories, we have the formula TP equal to C into VP. TP equal to total pressure loss. C is dimensionless loss coefficient for duct fittings and accessories. VP is velocity pressure. Velocity pressure can be calculated by this formula VP equal to V divided by 4005 square. If you need to make manual calculation for external static pressure, you need to find the value of friction loss rate and velocity from the friction loss chart. Then to apply this value in this basic formula to calculate the total external static pressure. To make easy to understand, I will do one simple exercise to find the friction loss rate and velocity using the friction loss chart. As we have 4 rectangular duct sizes, in order to use the friction loss chart, we need to find the equivalent round diameter for these duct sizes using SMACNA table. Using table 14-2, we have selected the equivalent round diameter for the rectangular duct sizes. You can see for the duct size 28 by 16 inch, the equivalent round diameter is 22.9. And for the size 20 by 16 inch, the equivalent round diameter is 19.5 inch. For the duct size 16 by 12 inch, equivalent round diameter is 15.1 inch. And for the duct size 12 by 10 inch, the equivalent round diameter is 12 inch. After selecting the equivalent round diameter for the corresponding rectangular duct size, we will apply this round dia value and CFM value in the friction loss chart to find the friction loss rate and velocity for the duct. After applying the value of CFM and round diameter on the friction loss chart from SMACNA, we will find the value of friction loss equal to 0.09 water gauge per 100 feet and the velocity equal to 1250 fpm. Excel sheets used in this calculation is created by me based on the concept in ASHRAE, SMACNA and Carrier handbooks. To get these Excel sheets, charts and tables used in this calculation, you can contact me on efga87811@gmail.com.